First of all, thank you to the bartenders for keeping us sober during the making of this content. So if you guys want to remain anonymous at the beginning of the video, click the join button below in or join the membership. From the evolution of many species into jellyfish forms to the transparent creatures at the bottom of the deep ocean, we have witnessed so many strange organisms in the journey of exploring the world. But when it comes to aliens, you always think they have a humanoid shape like us. Bipedal creatures with two arms and standing upright. But are they really like that? What makes us believe aliens will have such a structure, and what makes us think aliens cannot be made up of things we cannot comprehend, against what to the way? The first important question we need to ask is, what is life? If the answer seems quite easy. We just need to look outside, look in the mirror, anywhere we will see life. We are living on a living planet with creatures living in the sky, under the sea, on the ground, and even on our eyelashes. But when defining life, we find it hard to define this concept. Life is breathing air, grinding rough nutrients, digesting new forms, then excreting and digested substances. Maybe that is life because any living creature is doing that, absorbing nutrients and excreting waste. That is one of the many common points we can identify when referring to life, whether animal or plant. As long as it still has metabolism, it is still alive. But apart from this common point, do we have any others? The answer will be yes, there are many others. What we need to focus on the factor we often overlook when referring to the concept of living things, which is the structure of cells. At the microscopic level, living things not only metabolize in the form of food and waste, they also metabolize within their own bodies within each cell. Our cells are made up of bonded molecules connected to each other by organic compounds integrating inorganic and organic compounds to produce another compounds, and continue that process. All living things are like that, made up of cells, and these cells are all made up of organic matter. Interestingly, everything alive is made up of organic matter. So what is organic matter the basis of life? Surprisingly, the answer is no. Carbon is an extremely familiar and special element to our planet because all forms of life on Earth are made up of carbon atoms. More specifically, carbon is the substance that has connected other substances to form chains of substances capable of diverse transformations, creating conditions for the miracles of creation to form. Carbon is a special substance with extremely strong bonds with other elements. Firstly, they have four hands to hold on tightly to the elements around them, and especially to hold on tightly to themselves. These carbon bonds are the lifeline for all organic compounds. From these organic chains comes the blueprint for life, DNA. DNA determines the existence of species. Without DNA, no creatures can exist, be born, maintain a species. And DNA cannot exist without the unique, stable connections of carbon. This is the biggest commonality of all living things on this blue planet. Everything from plants to animals, from the sky down to the sea, exists thanks to the complex yet delicate structures created from carbon. Why is it like that? Why is carbon so miraculous? First, we need to consider the types of bonds that allow life to exist. We cannot throw all the chemicals together in a flask and shake it up to create life. It needs to have special bonds connecting the chemicals together in a certain order. The basic chemical bonds include ionic bonds, metallic bonds, and covalent bonds, and white bonds. Life cannot exist with metals, so we can eliminate that second element. Ionic bonds are too unstable to stably exist. So with covalent bonds, which element can we use as the linking substance to form organic chains like carbon? Looking at the periodic table, we can easily eliminate all the metals from the discussion. The highly flammable elements like fluorine, chlorine also need to go. The stable structures on the far right, like the noble gases helium and neon, because they do not like to react with anything else, will need to go. The elements with one Levite bond like hydrogen are also like that. Finally, what are we left with? Carbon, nitrogen, oxygen, silicon, phosphorus, and sulfur. Of all those substances above, only carbon has the best ability to form stable, covalent bonds. Not only bonds with itself, but also attracts the other siblings, so together form organic chains. But then when looking at the chubby little brother below named silicon, we have to ask, how is silicon different from carbon? Looking at the molecular structure and covalent bonding ability of silicon, we can easily see the potential for silicon-based life. Firstly, silicon also has 4 free electrons that can form similar covalent bonds like carbon. It can bond with base groups, self-bond to form organic chains. Next, if we look at the planetary structure and molecular issues, we can easily see silicon makes up a large part under the Earth's surface, sand everywhere, rocks everywhere, while carbon is mainly found in coal. Heavy substances are the air. So for a living organism to exist in silicon form, it does not need to spend too much effort to collect silicon and create silicon DNA chains, because silicon is silicon-bent. But this is a big problem, a very big problem. Our world is covered by the stable compound called tow. In other words, it is very wet. Water is an extremely important solvent for life because it provides a space for molecules to move, from which they can build larger molecular structures like organic chains. But why is water a big problem? Water is quite a stable compound, able to dissolve many different substances without affecting their molecular structure. There are extremely few chemicals that are like the oil, but all these few, we have a silicon. Silicon in its elemental form reacts strongly with water, absorbing oxygen molecules to release hydrogen gas. The product will be silicon dioxide or silica, something we can easily find everywhere because it is sand, and sand is chemically non-reactive to continue releasing silicon in the natural environment. In the form of silicate crystals, it can become beautiful quartz. But we do not want quartz in our bodies. Water is unlikely to be a solvent for silicon because when silicon molecules separate to form organic chains, silicon molecules easily combine with water, releasing hydrogen and forming sand. So silicon-based organisms will not be able to exist together with water. But water is not the only solvent. Apart from water, we also have acids, alcohols, ammonia, and the list goes on. However, we can clearly see that water is always the most abundant solvent on Earth. In order for silicon-based life to form, it would have to exist in an environment where other solvents rule. And do we have planets with methanol, ethanol, or ammonia oceans? In fact, there are. And this is an extremely important clue for astronomers. Since modern chemistry has been developed, we've come to understand on our own that water is the wisest choice for life. It's everywhere, easily accessible, and easy to use. Additionally, water does not react strongly with oxygen like organic solvents. Therefore, living organisms can use it as a habitat and then evolve in it. However, thanks to the development of relativity, we have also realized life can choose other solvents if their bodies are made up of other substances. From here, works like Psychology, an introduction to the scientific study of extraterrestrial life, intelligence, and civilization by American nanotechnology researcher Robert A. Freitas Jr. in chapter 8, Exotic Biomania, specifically ammonia. Ammonia is one of the most abundant waste materials on the surfaces of planets, especially the atmospheres of gas giant planets and the cold moons of these planets, and even on Earth in the primordial era. So the issue of ammonia oceans has been solved. So how are the solvent properties of ammonia? Ammonia can dissolve many substances, even more effectively than water. Ammonia can directly dissolve sodium, magnesium, aluminum, and many other substances. This is why ammonia is often used as a cleaning agent. But that's not all. In an ammonia environment, complex compounds like proteins and nucleic acids can form. Liquid ammonia can support organic chemical systems as in water. Ammonia-based cells can more easily access metals like magnesium and aluminum. Phosphorus and sulfur are 2 important elements in DNA formation. Can also easily dissolve in ammonia with minimal reaction. However, ammonia can boil at a very low temperature. Instead of boiling at 100 water, ammonia bubbles up. Veggie-3D. But in other environments like the moons of Saturn and Jupiter, even on those planets themselves, everything will be very different. The atmospheric pressure and gravity of these planets are completely different, creating conditions for a completely different environment on these planets. Ammonia will boil it around and eat it, which is almost perfect for life. Ammonium is almost a perfect solvent to replace water. But this is an extremely generalized perspective. Looking more closely at the chemical properties and molecular bonding abilities of water and ammonia, they are fundamentally two very different substances, almost opposites. Life in ammonia cannot live in water and vice versa. Additional hydrogen bonds in the ammonia world are not as stable as they are in water. Nitrogen is essentially a more inert gas compared to oxygen, so ammonia bonds are easily broken. In short, organisms living in ammonia will easily be destroyed if there are changes in temperature. With the cycles of increasing and decreasing temperatures on Earth, we can understand how lucky we are that coverup-based life can swim in water instead of swimming in ammonia. Additionally, while protein structures can form in ammonia, it is uncertain whether they can stably exist to continue building higher-level structures. From that, a complex multi-layered protein structure like DNA would be very difficult to form, and just when everything seems difficult enough, we have even more challenges. Ammonia is highly flammable in oxygen. That makes it so organisms living in an ammonia world cannot breathe oxygen, or they have to respire and metabolize with another gas. Additionally, radiation like coverup will destroy molecular structures, causing water to dissociate into oxygen and accumulate into ozone. The existence of ozone is an almost prerequisite for life because it shields the planet from the effects of solar radiation. But with ammonia it's different. Ammonia is dissociated into nitrogen, and nitrogen cannot protect the planet from solar radiation. Organisms living in an ammonia world would have to burrow deep down to be able to escape cosmic radiation from the central star. So although it seems that ammonia-based life is unlikely to form with the infinite creativity of the universe, somewhere out there may be a world without oxygen. Only ammonia seas where silicon-based organisms are swimming in ammonia seas that we are in a water. With the eyes of brilliant astronomers like Carl Sagan, the existence of water and carbon-based life is not essential. So the existence of life on other bases is completely possible. But so far we have not had any evidence for life other than ourselves, carbon-based organisms. So as Carl Sagan himself said, the absence of evidence often leads to the mistake of thinking that it is evidence of absence. The fact that we have not found evidence of silicon or ammonia-based life is not proof that such a life does not exist. Simply means we have not found it yet or not discovered it yet. And that's why the search for extraterrestrial life must continue. But in that journey we need a broader view of the concept of life. Life does not necessarily have to follow any framework. The life of life may not be the only model. Extraterrestrial life may be in forms we cannot understand or imagine. So in order to truly find and think of aliens, let's let go of all the imagery we've ever had of these creatures, and let the creator give us the most amazing stories. And there's a story of alien imagery, the possibility of extraterrestrial life down in what form. Could it live on water and breathe oxygen like us? Or will it live in ammonia, made of silicon, and breathe sand? Perhaps only time will give us the most accurate answers. If you like this video, click like, subscribe to us, and click the notification bell so you don't miss any videos in the future. Additionally, you can directly support us by clicking the thanks button below, with the join button to join the membership and receive exclusive videos. Thank you for listening, and see you again.